Welcome back, guys. In this new video, we're going to take a look at the energy changes involved in our chemical reactions. Now, first off, we're going to start off by saying that blank is the branch of physical science concerned with heat and its transformations to and from other forms of energy. So we're going to say that this is called thermodynamics. Now, the part of thermodynamics that we're going to be concerned with is the branch of chemistry that deals with the heat involved in our chemical and physical changes. This branch of chemistry is called thermal chemistry. And remember, when we use the term energy or we use the term heat, they mean the same thing. Heat is just a type of energy, okay? It's thermal energy, okay? Energy of heat. And when we're talking about thermal energy or heat or energy, we're talking about two basic ideas. Okay, we're talking about the specific part of the universe that we're focused on. Since we're in a chemistry course, our system is the part of the universe that we're concerned with. And when I say system, I mean our balanced chemical reactions. Okay, so any balanced chemical reaction that we're paying attention to when doing word problems, when looking at it on the board when our professor is talking about it, that represents our system, our balanced chemical reaction. Now we're going to say everything having to do with that balanced chemical reaction represents our system. Everything outside of that, you, me, your professor, the board in which they're talking about, all of that stuff are our surroundings. So we have our system and we have our surroundings. And they're not isolated from another. Whatever happens to one, the opposite happens to the other. So if our system is gaining energy, the only reason it's gaining energy is because the surroundings are giving that energy to the system. So as a result, the surroundings would be losing energy. It also works the opposite way too. Okay, so our main concern are which way is energy traveling? Is it going from our surroundings to our system or our system to our surroundings? We're going to say when talking about the movement of energy or heat between these two guys, between the system and the surroundings, we use the terms endothermic and exothermic. Now, here I give us two equations, okay? And I basically put them in boxes. And I'm telling you that I'm putting them in boxes to show you that these are our two balanced chemical reactions. So they represent our system. Everything within that box is our system. Anything outside that box represents our surroundings, okay? So inside of here, our balanced equation, that's our system. This here, this box over here, is outside of that box, so it must represent our surroundings. Now, we're going to say here in this reaction, we're going to say that the system absorbs energy from the surroundings, okay? So this is our system, this is our surroundings. Our system is going to absorb energy. So if it's going to absorb energy, that energy, which is heat, is going to go here as a reactant. And when our system absorbs energy from the surroundings, then it is an endothermic reaction. Okay? So remember, system absorbs energy from the surroundings, it's endothermic. And what you should also notice is, take a look, we start off with one product, but at the end of the reaction, it's broken up into two products. So we're going to say an endothermic reaction is energy absorbing and, more importantly, bond breaking. Just think of it like in these terms. Why do compounds absorb energy? They absorb energy so that they can use that energy to break their bonds, to free themselves. Okay, so this is an endothermic reaction. In the next box, we say that where our balanced chemical equation is, that's our system. Everything outside of that is our surroundings. Here, we're going to say that the system releases heat. It releases energy or heat to the surroundings. Okay, so now heat is here, and it's being released to the surroundings. So we're going to say anytime our system releases heat, it's exothermic. And take a look. We start off with two different reactants that combine to give us one type of product. So we're going to say an exothermic reaction is energy or heat releasing. and bond forming. These molecules are releasing energy, so they become more sluggish. They become slower because they're losing energy. They slow down enough that they start to clump together. They clump together enough that we can go from having just multiple reactants to just having one or two products. Okay, so that's the way it works. So just remember these two important concepts, and remember, do they involve the releasing or absorbing of energy? And who's gaining energy and who's losing energy? Is it the system or is it the surroundings? Now that we've seen this, let's take a look here. For this example, we have to classify each of the following as being either an exothermic or an endothermic reaction. Since we might need some space here, I'm going to take myself out of the image, guys, so that we have more room to work with. Okay. Now, the most important thing here is you may not necessarily know what each of these are, aqueous water, what that means, or water vapor. That's not important. The more important thing here is the terms that I use. Sublimation, vaporization, deposition, condensation. The most important thing to understand is, what do these things mean? Now, we said that exothermic reactions are bond forming. We need to realize the trend here. If we're forming bonds, that means we're going usually from gas to liquid to solid. That is the trend for exothermic reactions. For endo, we're breaking bonds, so we're going from solid to liquid to gas. So remember those trends. For the first one, fusion of ice. Fusion is just another fancy way of saying melting. Okay, so fusion equals melting. And when it comes to melting, what's melting? We say that ice sometimes melts, right? So solid ice can melt to liquid water. So we're going from solid to liquid, so we're breaking bonds. So this would be endo, sorry, because we're breaking bonds. Sublimation. Sublimation, that means we're going from solid straight to gas. This can happen. Sometimes the pressure and the temperatures are low enough that certain compounds don't have a liquid phase. Under low temperatures and pressures, they go straight from solid to gas. Again, we're breaking bonds, so here this would be endo. Vaporization, we vaporize water, so it goes from liquid to gas, so we're breaking bonds, so this is endo. Deposition, deposition is just the opposite of sublimation. We go straight from gas to solid. We deposit a solid. So this would be exo since we're forming bonds. And then finally, condensation. Condensing of gas in the air forms like little bits of water on plants. So condensation is going from gas to liquid. Forming bonds, so it's exo. Now that we know what endothermic and exothermic reactions mean, remember, apply that to what we've learned about systems and surroundings. One is gaining or losing energy at the cost of the other. As long as you can remember the direction energy is going, you'll be able to apply the concepts we learned here to answer questions later on.